Hello guys, I hope you're all good, you're all enjoying from wherever you are watching us. Now let's look at Euclidean geometry, the father of paper 2, the hardest or the easiest one. So it's either it's gonna be hard or it's gonna be easy for you. So let's look at this Euclidean geometry and I hope everyone is gonna enjoy. Please make it a point that you ask your questions on the chat section, or you can actually interact with us on our WhatsApp interface. Okay, now let's look at the question and let's get this ball rolling, guys. Euclidean geometry. Now in Euclidean geometry, it's just a summary from grade 11 and I think grade 10 as well. So we are combining all the information which have learned so far, and now we are applying it, the different theorems. In all grade 12 we only do the prop theorem as well as the similarity theorem. So everything you've already done it in your previous year. So we have already covered the trigonometric video. Now we want to check the Euclidean geometry. So question number 8. Question number 8. Question number 8. Let's look at question number 8, guys. Now, in the diagram below, O is the center of the circle passing through ABC. CAB is 48 degrees. COB is equal to X. C2 is equal to Y. Okay, great. So you can say that, okay. Okay, angle at the center is twice angle at the circumference. In Euclidean geometry, we believe in reasoning. Why are you saying this angle is equal to this angle? Why are you saying this is equal to this angle? Why are you saying this and this? So let's look at it. Angle at the center twice at the circumference. Angle at the center twice at the circumference. Okay, so now let's look at this and let's work on that. Determine the value of x. Guys, x is equal to, let's do this. X is equal to it's 8.1.1. So x will be equal to 96. Okay, that will be 48 times y, angle at the center twice at the circumference. Okay, so angle at the center is equal to 2 times angle at the circumference. Then that's that, and we are done. Now let's look at 8.1.2. what is y? How do we find the value of y in the question? So we can see that that's where our y is, and we can see that, oh okay, OC is equal to OB. They are all attaching from the center and going to the circumference. So we call them radii. Any line joined from the center to the circumference of the circle is radii. So in other words, that triangle OCB is what we call an isosceles triangle, because we can see that this is our center O, then it's coming to C and B and forms a triangle, and we know that OC is equal to OB and it's a radii, and we know that if those two sides are equal to each other, which means we are considering this triangle to be an isosceles triangle. So of course we have our B2 also, which is going to be equal to Y. Y, angles opposite, equal sides. Okay, so Y is equal to B2. Let me just say B2 is equal to Y. Y, angles opposite, equal sides. Why are they equal sides? Someone will ask me. Because there is what we call a radii. Let me just write it here. We say OC is equal to OB. They are radii. So that's already an isosceles triangle. So now we can sum all the angles. So we can say angle, that 96 degrees plus y is equal to 180 degrees. Okay, this is in triangle OCB. What's the reason? Sum angles in a triangle. The beauty of Euclidean geometry, because we are summing everything in our triangle now which we have formed. Okay, so this will be 96 degrees plus 2y is equal to 180 degrees. Then 2y will be equal to 180 degrees minus 96 degrees. Then 2y will be equal to what? 180 minus 96. That's 84. Then we divide by 2, then our value of y will be equal to 84 divided by 2, which is equal to 42. So our value of y is equal to 42 degrees. Just like that, the beauty of Euclidean geometry. Now let's look at the next question which we have. Okay, in the diagram below, so what do they want? O is the center of this circle passing through A, B, C, and D. AOD is a straight line, and F is the midpoint of chord CD. ODF is equal to 30 degrees. Okay, where is ODF? ODF. Oh, there is our 30 degrees. Boom. Determine with reasons the size of F1 and ABC. Okay, let's do it. We are in a good mood today, okay? So 8.2.1. Now we can now determine our angle F1 there. So F1 will be equal to 1. Now let's look at our diagram clearly. So we can actually see that, okay, CF is equal to FD. They've given us in the diagram, and we can actually see that we have OA, we also have OD, and they told us O is the center of the circle, which means AO is actually also equal to OD radi. The moment a line is drawn from the center to the circumference of the circle, that's already a radi there. Oh, okay. I can sense that we're gonna have 1, 2, 3. We actually also have a cyclic chord in that circle. Do you see that? O, D, C, B. Okay. A, D, C, B is a cyclic chord, but it's fine. Let's determine F1. How do we find F1? Where is F1? F1 is there. Okay, so how do we find F1? Okay, of course, F1 is equal to 90 degrees. Why is F1 equal to 90 degrees? Because line from the center bisects the chord which we have. Okay, so that's already easy as that, because we're already seeing what we are doing and what we are dealing with. So F1 is equal to 90 degrees because we have already seen that CF is equal to FD. Those two sides are equal to each other. So by virtue of that, we already see that also OF bisects the chord. So F1 is equal to 90 degrees because line from the center bisects the chord. Just like that, and we are out. Now they want us to determine angle ABC. Where is ABC? ABC. So they want that angle B. So we can actually see that B is easy to find because I have highlighted that ADCB is a cyclic chord. So if we say angle B plus angle D is equal to 180 degrees, the reason is opposite angles of a cyclic chord. Then Euclidean geometry is so nice. Euclidean geometry is super nice. Okay, so 8.2.2, we are saying that angle ABC plus 30 degrees is equal to 180 degrees. Why? Angles opposite angles of cyclic chord. This is so nice. So now ABC is equal to 180 degrees minus 30, then which is equal to 150 degrees. So the angle they've asked us is equal to 150 degrees. Just like that, we are happy. Okay, this is the beauty of Euclidean geometry. So please make sure that you don't do any mistakes. Okay, now 8.3, in the diagram below, B is the center of the circle. Oh my word, we have another center of the circle again. So we are also told that AK is equal to KB is equal to BC. AK, okay, that's the line, is equal to KB. Okay, that's another line, is equal to BC. We can actually see that in the diagram which we have those two lines equal, showing that these lines are equal to each other. And we are also given AKD, which is angle K is equal to 108. AKD. So you can see that that angle is equal to 108. Okay, and angle A is equal to X. So what do they want? Express B1 in terms of X. Where is B1? There is B1. They want us to express it in terms of X. Oh, guys, do you see that we have a triangle ABK there? Then you can see that if we say B1 plus angle A, that angle A, which is X, is equal to 180 degrees, then we say that exterior angle of a triangle. That's the answer. Or we can actually see that, okay, B1 is actually equal to X. Why is it equal to X? We can actually see that, oh, okay, KB is equal to AK, which means opposite angles equal sides. 8.4, Okay, so that one is straightforward. So 8.3.1. So you can actually do this in different ways. But of course, now that I'm saying that, okay, AK is equal to KB, which means that's an isosceles triangle. So let's just say in triangle AKB, okay, we can actually see that AB, AK is equal to BK. Reason it's given, okay, they're equal sides, so therefore B1 is equal to X, okay. Let's just say it's equal to angle that X, okay, yes. Why is that equal to X? Because angles opposite equal sides, okay. These sides are equal. Then now 8.3.2, show that angle C is equal to X over 2. That's scary. Why is it X over 2? Anyone who knows, just type in the comment section. Why is C equal to X over 2? It's like 2 marks, guys, okay. Why is it that? Any answer will be appreciated. So what I've learned for so far, that in Euclidean geometry, or generally in Euclidean geometry, or any question, all the questions, they are building blocks for all the answers which you're gonna have. So if we now look in triangle BKC, okay, we can see that K2 plus angle C is equal to that B1, exterior angle of that triangle, okay. We can actually see that, okay, this is what's happening there. They are equal to each other, and that's amazing. So what do we do from now? We need to know what is K1, and everything will be perfect. We can calculate K1, but this is also another point we can see. So there are always many ways to kill a cat, but now let's look at this other point which we can also use in this question, okay. So now that we know that this one is X and X, so we can actually say that K1 plus B1 plus that angle A is equal to 180 degrees, some angles of a triangle. Then that will be K1 is equal to 180 degrees minus 2x. Why? This is x plus x. So now we have K1. Now we want to know the value of C. How do we calculate the value of C there? So we can actually see that K2, which we have already written down there, we want to know K2, but is it important to know K2? Let's check. So if now we say 180 plus that, then that will be what? Oh yes. So this will be 108 plus 180 degrees minus 2x, okay, plus x over 2 is equal to 180 degrees, okay, because this is what we know, okay. So from that we can actually see that, oh, okay, this and this cancel, then that will be negative 1 over 2, you got negative 108, then x will be equal to 72 degrees, okay. Okay, then after that we are happy, okay, because that's negative 2 plus 1, that's negative, then after that we have x to be 72 degrees. So actually we were answering for x. Oh, we didn't answer properly 8.3.2, we were answering 8.3.2. let's rectify that mistake, okay. So 8.3.2, there was a bit my mistake, okay. We can see that K2 plus C is equal to x. No, we did answer it here, but let's just do it again. So K2 plus C is equal to x. Y, exterior angle of the triangle. Which triangle is that? The triangle PKC, okay. Then after that, we can see that angle C is equal to angle K2, y angles opposite equal sides. Okay, they have sides which are equal to each other. Then we can see that, oh, okay, this is easy. X is equal to x over C is equal to x over 2, because this will be now x plus C. Then after that, you can actually see that, okay, this is what's going on there. Then we have our correct answer. Then now moving forward to what we want, that will be x over 2. Then we can now calculate 8.3.3. Then now that's when we say that K1 is equal to 180 degrees minus this. So this is where we are. Okay, so we say that K1 plus B1 plus angle A is equal to 180 degrees. What's the reason? Sum angles of a triangle. Okay, then after that, K1 will be equal to, this was x, this is also x, so it's going to be 180 degrees minus 2x. Now looking at the straight line there, we can actually see that 108 plus 180 degrees minus 2x plus our x over 2 there is equal to 180 degrees, because now we want to solve for x, and the reason will be angles on a straight line. Okay, angles on a straight line, then our x here will just be 72 degrees. Okay, as simple as that. Now let's look at the next question. Refer to the diagram below. O is the center. Oh my word, O is the center again. Now of the circle, E, F, and G and H on the circumference of the circle. Prove the theorem that says angle E plus G is equal to 180. So in other words, they want you to prove that that rule says opposite angles of a cyclic quad are supplementary. That's what you're supposed to prove. So that one, you just look at your theorems and you prove. So let's do question 10, which is our last question of today. Now on question number 10. Question number 10. In the diagram below, FED is the tangent to the circle passing through A, C, E, and F. Is the center of the circle. Okay, F is our center of the circle. Where is F? Yeah, there is F. We can actually see that EF will be equal to AF. Then AC is extended to meet ED at D, and FB bisects AC. Okay, straight lines FD, BE, EC are drawn as well. All right, now prove with reason that EFBD is a cyclic quadrilateral. How can we prove that EF, okay, EFBD is a cyclic quad? How can we prove that? So to prove that, guys, it's so easy, because we can actually see that FE is parallel to DE, is perpendicular to DE. We can see that all of us, FE is perpendicular to DE. Why? Its radius perpendicular to the tangent, because we say that a radius is a line from the center, drawn from the center to the circumference of the circle. So let's do this question fast, guys, and we enjoy it as we can. 10.1, we are saying that FE is perpendicular to DE, Y radi perpendicular to the tangent. Okay, then after that, we can actually see that if that's the case, which means that FED is equal to 90 degrees, because when they are perpendicular lines, they form a 90 degrees angle. Then also, which means that FB angle A is equal to 90 degrees again, but this one is because line from the center, it bisects the chord. As you can see that those two lines there, they are equal to each other. AB is equal to BC. So with that being said, that gives us a go ahead to actually say that line from the center, which is from F, they bisect the chord, so that's also 90 degrees. Okay, then actually we can actually see that therefore EFBD is a cyclic quad. The reason is opposite angles equal to 180 degrees. So if we add these two opposite angles, we can actually see that they will give us what we call 90 degrees. So please be careful of that question. It was not really hard, it just wanted you to think a little bit more and be able to have the correct answer in due time. Now let's proceed to 10.2. Now let's proceed to 10.2. Now 10.2 is saying prove with reasons that triangle BCE is similar to triangle FED. So how do we do that? We say that the first thing which is important when solving this kind of problems or this kind of question is for you to just write it down so that we can be able to see what's going on. First thing which you do is that you write these two things, 10.2, in triangle BCE and triangle FED, so that we can see which two triangles are you talking about. Now let's look for similar things in these two triangles. We have BCE, yes, then we also have triangle FED. So what or where can we start there? Okay, so we can actually see that angle C1 is 90 degrees. Why? This is because this is the angle in a semicircle. Let me show my screen there. Why? It's because that's an angle in a semicircle. Okay, so that's angle in a semicircle. Because bear in mind that AFE, that's already a diameter because it's coming from a circumference and passes through the center and goes to the other point on the circumference. So that is giving us a right to say that this is an angle in a semicircle. So we can actually see that in these two triangles, C1 also will be equal to FED, which is equal to 90 degrees. Also B2 is equal to F1. Why? Angles in same segment. Then we can actually see that which other angle do we have here. We can actually see that E2 is equal to angle D1. Then we can actually just say third angle of a triangle. Then therefore triangle BCE is similar to triangle FED. What's the reason? Angle. Then everyone is happy with that because that's already easy. It's an angle there. Okay, now let's look at the following question, 10.3. Prove with reason that BC is that. Guys, that's already easy, guys, because we can now use our prop theorem, okay, or similar triangles theorem. So to solve that or to prove that, the first thing we're just using from these two triangles, we can actually see that BC over FE is equal to what? Is equal to CE over ED. Then we can just say similar triangles, okay? Because we've proved it. So it's now our right to use it. So we can just say it's because of similar triangles. Then as a result, we just make BC to be the subject of the formula there. Then that therefore BC will be equal to FA times CE divided by ED. Okay, then we're just happy because of course we know that FA and FE, they're equal to each other. So that's why we are saying this is the correct way, or this is the correct reason. Why are they equal to each other? Someone asking even now. We say that line from the center to the circumference is a radius, so we can actually say that FA is equal to FE. Let me write it down. So FA is equal to FE, it's radi. Then yeah, we are happy with that question. Then the last question, prove with reason that BC is equal to that, and that's 4 marks now. So after that, you can actually also be able to prove it. That's 10.4. How do we write that question? Of course, we know that FBA is equal to angle C1 is equal to 90 degrees, and we have already proved it above. Okay, so that's already proved. Then from that we can actually detect that FB is parallel to CE. Okay, because of those, then now we can write that we have our corresponding angles. We have our corresponding angles there. Okay, just a minute. Sorry about that, but yes, then we can actually see that since they are both equal to 90 degrees, therefore FB is parallel to CE. Those are our corresponding angles. Okay, then after that we can see that since these are corresponding angles, now we can introduce what you've been taught in grade 12, that's prop theorem. Then we can actually see that AC over BC is equal to AE over FE. Then what's the reason now? That's when you say that line parallel to one side of the triangle, which is the prop theorem. Okay, then we state the parallel side. Then after that we can make BC the subject of the formula. Then that will be AC times FE divided by AE. Then you get your 4 marks just like that. So this is our Euclidean geometry. So let's calculate the total marks for Euclidean geometry in this question. It was 17 plus 6. Let's see. 17 plus 6 plus 17 yes, so this one was 40. Wow. So in other words is that we should realize that Euclidean geometry in this exam was 40 marks and trigonometry was 51 marks. So that's already 100 and something. You're already level 5, level 6. So guys, these two topics are so important. Till we meet again, have a great evening.